My name is Kok Yong Sian from BMKV Section 2 Group 1. This presentation video is about the Set 1 Questions 1 explanation videos of static assignment. This question is about root truss, and here are some definitions about the root truss. Root truss is a plain truss is an arrangement of bars which are connected end to end in such a manner as to form a rigid framework. To analyze the internal force in each member of a truss, there are some methods that we use, that we learn in our lecture, which is method of joint and method of sections are used in these questions. Let's move on to these questions 1. So, free body diagrams of the overall free body diagram is drawn. First of all, we need to find the reaction force first before we move on to find the forces of each members. So, there are 3 reaction forces in these questions, which are AX, AY, and LY. By finding the reaction force at L verticals, we can apply the moments of A is equals to 0, and we can find the reaction force at LY is equals to 1.5 kN, which are in tension form. Since there is no vertical force applied in the horizontals, so AX is equals to 0. And for AY, we let the force in equilibrium at verticals, which is Fy is equals to 0. Hence, we can find the AY is equals to 4.5 kilonewtons, and which is also under tension. Now we apply the methods of sections and we cut through DF, EG and DG. Now we will need the values of perpendicular G and G prime from point G to the bar DF, and D and D prime from point D to the bar EG in this step. So we need to calculate the length of 2 perpendiculars first. So we're using the triangle DFG. You can find the theta is 26.565 and the alpha is 63.435. After that, we can find the length of G and G prime, which is 1.789. This is one of the perpendiculars we need to find, and after that we apply the same method, which is trigonometry, and we find the D and D prime, which is same as G prime, 1.789. After that, we let the moment of G is equal to 0, and we calculate the value of FDF is equals to minus 5.031, which is under compressions. And after that, we use the same method with moment of D is equals to 0, and we can find the force at EG is 8.944, and it is under tensions. After that, we let the horizontal forces is equals to 0, and we can find the FDG is equals to 1.117. After that, we apply the second sections, which we cut through ED, EG, and BD. So same method we use, which is the horizontal forces is equal to zeros, and we apply all the forces at the horizontals is equal to zeros, and we can find the force at BD is equals to minus 11.313 kilonewtons, and it is under compressions. And after that, the vertical components is equal to zeros, and we substitute all the we substitute all the forces inside, and we can get the forces at ED is equal to 2.5 kilonewtons, and which is under tensions. Now for the third sections, we cut through the line BD, CD, and DE. So in this case, the left side is more smaller, so we can find the each member easily. So we apply moment at A is equal to zeros, and we can find the forces on BE is equal to minus 2 kilonewton, and it is under compressions. And we apply the force at vertical is equal to zeros and substitute all the point inside, and we get the force at CE is equal to 11.18 kilonewton, and it is at tensions. After that, the fourth sections we cut through is at BC, AB, and CE. So we apply the moment at A is equal to 0. We can find the FBC easily, and it's just 0. No force acting on that member. So after that, Fx is equal to 0, and we substitute inside and find the force at AB is equal to minus 14.142 kilonewton, and it is under compressions. Now, we don't need to cut any more section now. We can calculate the value of the internal force in the truss member AC simply by consider joint C in equilibrium, which gives us that the internal force in bar AC is the same as that in EC. So now we're finding the force at AC by using method of joint. So we no need to cut through any of the point. So we just add the point. So we apply Fx is equal to 0. Now we involve all the force in the horizontal components to find FAC, and FAC is equal to 11.18 kilonewtons. And the last one, we finding the force at DG. So at joint D, the free body diagram is drawn, and after that we apply the horizontal force is equal to 0, and substitute all the forces verticals is in equilibrium, and we can find the force of DG is equals to minus 3.913 kilonewton, which is under compressions. Here are the all explanation about these questions 1, set 1 questions.
Okay, now for question 2 for set 1, here we have the free body diagram for the figure. So the first thing that it wants is the reaction at A and F. So A and F is spin support. So we're gonna have two reaction for both of the support. So that's AYAS and FYFX. So we're gonna write the equation sum of fx is equal to 0, sum of fy is equal to 0, and sum of moment is equal to 0. So the first thing we're going to find is the moment, sum of moment at A. So sum of moment at A is 0. So to determine it, we're going to find force that is perpendicular to A. So force that is perpendicular to point A is Fy and 30 kilonewton. So Fy, the perpendicular we have to times it with the perpendicular distance. So Fy times 6 minus 30 kilonewton times 9. 6 plus 3 is 9. So Y negative because the 30 kilonewton will produce clockwise motion. So it's negative. So 6 Fy is equal to 270 and Fy is equal to 45. Okay, right now we're gonna find sum of Fy. So sum of Fy is 0. So Ay plus Fy minus 30 is 0. So we rearrange it. It became Ay plus Fy is equal to 30. So right now we have the value for Fy, which is 45. So we're going to substitute it in this equation. So Ay plus 45 is 30. So Ay is going to come out as negative 15. So right now, after that, we're going to uh, calculate for sum of Fx. So sum of Fx is 0. So Ax plus Fx is 0. Since we don't have any force uh, at x, so we're just going to assume that Ax is equal to negative Fx. So to further the calculation, we have to determine the angle for the calculation. So we're going to draw this triangle. So the only thing given to us is the length, which is 6 meter, and the height, which is 8 meter. So we have to use Pythagoras theorem. So 8 square plus 6 square, and then square root 8, we're gonna get 10. So 8, 6, 10. Okay, right now we're gonna find the force at joint A. So FAE minus FAB cos theta is equal to 0. So FAE is equal to FAB cos theta. So to find FAB cos, so this is the first equation, and then we're gonna write the second equation, which is AY plus FAB sin theta is equal to 0. So we know that AY is negative 15. So negative 15, if we bring it over here, it will be positive. So it's 15, and then we're gonna divide it with sine theta. Okay, so FAB equals to 15 times 5 over 4. Why we gonna multiply it with 5 over 4? So it state that it is sine theta. So sine is opposite hypotenuse. So the opposite is 8 meter. The hypotenuse is 10. So 4 over 5. But then we have to divide it. So we have to turn it around. So 5 over 4. Okay. Hypotenuse over the opposite. So we're going to get FAB 18.75. So right now we have FAB, so we can find FAE. So FAE, we put the value of FAB in the equation back. So FAE is FAE minus 18.75 times 3 over 5. So 3 over 5 is the cos theta. So here 6 over 10 is 3 over 5 is equal to 0. So FAE is 11.25. So right now we're going to move to joint E. So joint E, we got FBE cos theta is minus FAE equals to 0. So FBE is equal to FAE over cos theta. So FBE equals to, we already got FAE just now. So FAE is 11.25 cos divide by cos theta, which is 3 over 5. But again, we have to turn it around. So it will be 11.25 times 5 over 3. And then we got FBE equals to 18.75. So at join E also, we got FEC. So we're going to find FEC. FEC minus FBE sine theta is equal to 0. So right now we already have FBE just now. So 18.75 times sine theta, which is 4 over 5. Sine opposite over hypotenuse, 8 over 10. So that is 4 over 5 is equal to 0. So we get FEC is equal to 15. So right now, the last one we're going to find is at joint F, which is FEF. So we can conclude that FEF is equal to FY. So FY is 45, which makes FEF is 45. So that is all for question 2 in set 1.
Hello, my name is Ishan Kumar. Today I am going to explain question number 3 from set 1. The press shovel is used to emboss a small seal E. Determine a vertical component of the force exerted on the seal. From the question, we know that this is a pin support will have two reactions. From this diagram, we need to draw a free body diagram. For this question, will be F2 free body diagram. First, the free body diagram of the rigid body, and second, free body diagram of seal. For the first free body diagram, we need to draw the outer line and with the active force, which is 250 Newton, and AX, AY, and FBD for 20 degree, which is over here. And for the free body diagram 2 is about the seal, which is D and E. For the first question, we need to find about the movement for movement A, which is counterclockwise is positive, sum of movement A equal to 0. By this, we need to know that FBD sine 20, which is over here, and the length is 200, and the degrees over here is 60, which is sine, plus with FBD cos 20, which is over here, and the length is 200 cos, the degree over here is 60, and minus with 250, and the length is 400 cos 15 over here, and plus with 200 cos 60 over here is over here, and equal to 0. By this, we know that sine 20 bracket 200 sine 60 degree is 59.24 FBD, plus with cos 20 bracket 200 cos 60, so will be 93.97 FBD. Then following 250 bracket 400 cos 15 plus 200 cos 60 bracket is 121,592.58. So by the equal to 0. So we can plus FBD. So when we plus both these, will be 153.2 FBD, equal to, this will be moved to this side, so we become positive. To find the FBD, we need to FBD equal to 121,592.58 divided by 153.21. So the answer will be FBD 793.63 Newton. By this, we need to find force of E, seal E. So as we know from free body diagram 2, Fx is 0, cause no reaction, so we need to find downside is positive, Fy equal to 0. So by this we know that Fe minus cos the y is downstairs, so FBD cos 20 degree equal to 0. So Fv minus, so we know that FBD is 793.63 Newton, so we need to substitute this on this, so Fe minus 793.63 cos 20 equal to 0. So we need to find Fe, so 79.3 cos 20 will be moved this side, so when we press calculator, 793.63 cos 20 will become 745.76 Newton, so we can simplify to become 746 Newton. So the direction is down. And for the reaction A, my teammate will explain.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Firas Shamir. My matrix number is 132410527. I will continue for question 3B to found the reaction at A. So we should found the Fx first. So Fx equal to 0. And then Ax minus to FBD sine 20 equal to 0. The FBD numbers are already found in question A. So AX minus 793.63 sine 20 equal to 0. And then we change the minus to positive. So AX equal to 793.63 sine 20. And then we'll calculate. The answer is 271.44 Newton, and then we simplify to become 271 Newton. And then we continue to find Fy. So Ay plus FBD cos 20 minus 250 equal to 0. And then we change the negative to become positive. So it become Ay plus 793.63 cos 20 equal to 250. And then we change the FBD to become a negative. So it become Ay equal to 250 minus 793.63 cos 20. So we'll calculate. The answer is negative 495.77 Newton, and then we simplify, it will become Ay equal to 496 Newton for downward. Thank you.